Hello everyone, welcome to the video on Nobel Prize in Physics for the year 2023. This year Nobel Prize in Physics is awarded to three of the researchers. The names are Pierre Agostini, Franz Kras and Annie L'Huillier. Their research work involves generating attosecond pulses of light which is used to study electron dynamics in matter. Looks complicated, but let me simplify it. Let us understand they have generated attosecond pulse light, and this pulse light is used to study electron dynamics or electron transition movements. Let me explain it in a simple sense. See, in intermediate we all studied about Heisenberg uncertainty principle. What Heisenberg said is, to determine the position and the velocity of electron is uncertain. It is not possible because the moment you see an electron, it will be moving with a lot of velocity. Because of that, you cannot identify the position as well as the velocity of the electron. The reason why it is uncertain is electron moves with a rapid velocity, and electron transitions, everything happens in attoseconds. Attoseconds means it happens in 10 to the power of minus 18th second. In that fast manner, electron transitions occurs. Hence, it used to be called as uncertainty principle. But this year, Nobel Prize physicists, what they did is, they have generated a tool to identify the electron transition movement. That is what the tool is called as attosecond pulse light. Now, let us understand certain other aspects. See, in molecular transitions or molecular movements or atomic reactions occurs in femtoscale. Femtoscale means the reaction velocity is in the time scale of femtoseconds. That means in 10 to the power of minus 15th second, atomic association dissociation occurs. It is called as molecular dynamics. Whereas electron dynamics or electron transition occurs in a time scale of 10 to the power of minus 18 second. Let us understand a common phenomena. Look at this. There is a hummingbird. Now, hummingbird wing speed is so high, per second 80 times the wing beats. So if you see with an eye or with a normal camera, you cannot get the exact picture of the wing movement because it appears as a wave-like movement. Just for the case, think about our fan. When it is revolving with high speed, you cannot see the individual wing of the fan. Rather, it appears as wave because our eye cannot see that. Similarly, if you want to take a picture of that, it cannot capture it. Now, when it can capture, see, if a camera aperture or shutter speed is more than 80 frames per second, then it can capture it. Now understand what is happening. If a camera can send a light and the light pulses are more than 80 per second, then it can get the picture of the bird and take it. Now look at this picture. This is with high resolution camera which can clearly see the wings of the hummingbird. Now the moral is, if you want to study electronic transitions which happens in attoscale, you need to generate a pulse with a frequency of attosecond. Now understand the frequency. See, all these subatomic particles has got wave nature as well as particular nature. The wave, when you see the wave, frequency means number of waves which are passing through a particular point. Attosecond frequency means for a particular point, 10 to the power of 18 waves are passing through that point. Then it can be called as attosecond pulse. Now this is what is generated by these three researchers. And how did they do it? They took noble gases and sent some laser with electromagnetic radiation. Now in the laser, electrons absorb this electromagnetic radiation and they jumped into higher excitatory states. This is nothing but spectroscopy, interaction of electromagnetic radiation with matter. And when the electromagnetic radiation frequency is in attosecond pulse, it is called as attosecond spectroscopy. So what happens? The radiation is taken by the electron jumps into higher energy levels. When it is coming down, it releases radiation, electromagnetic radiation. Multiple radiations are released. Look at the picture, multiple radiations are released. Now when two radiations overlap, there occurs a phenomenon called as interference. The similar frequency in phase waves, when they combine, the frequency increases, and that is called as constructive interference. And with this constructive interference, they have generated attosecond pulse of light. And this is shown on molecules to study the dynamics of electrons or the movement of electrons. And there are wide applications that these can be used to observe the electronic transitions, and they can rapidly transform insular matters to conductors, insulating material to conductors, and they can be also used in diagnostic, medical diagnostics. So this is about 2023 Nobel Prize in Physics. All the best.